Hey guys, it's Eddie the Magic Monk. In the next few lessons, I'm going to teach you guys probability to prepare you for a bit of senior maths, particularly Maths B. The first concept I want to talk about is discrete random variables. So by now, you guys should be quite familiar with variables. You guys have been talking about x and calculating what x is for quite a few years. So basically it is just a quantity that can change. Now we're going to talk about what is a discrete variable. A discrete variable is a variable which can only take a countable value. So if you can count something then you can store it in a discrete variable. So for example, we can let x equal the number of heads obtained from coin tosses. So you keep repeatedly tossing a coin, and you write down how many heads you have obtained. Then x is what we call a discrete variable. Okay, so what does the term random mean? Random simply means that you can't predict what it's going to be. So with x, if you are running an experiment where you're tossing a coin, there is no way that you would know for sure how many heads you can end up with from, let's say, 3 coin tosses, right? It's completely random as to how many heads you can get from tossing a coin. So that's why x, in this case, x would be called a discrete random variable. So let's talk about our next concept, which is called discrete probability distribution. So let's firstly talk about what a probability distribution is, right? We've already discussed what discrete is. Discrete is basically when you can count the values. So number of heads, number of people, number of pencils, number of something is discrete, where you can count it. So discrete probability distribution. So what is probability distribution? So let's draw up a simple table to explain that to you. So a probability distribution is simply the assignment of probabilities to all possible outcomes of an experiment. So let's say we have an experiment right here, and the experiment is that we're going to toss a coin 3 times. So the experiment right now is tossing a coin 3 times, and here are our possible results, right? If you toss a coin 3 times, you could end up with no heads, 1 head, 2 heads, or 3 heads, depending on how lucky you are. So these are the probabilities from getting these number of heads. Now, I will teach you guys how to get these probabilities later on. But let's say these are our probabilities, then this table here is our probability distribution, because it shows that a probability is assigned to every possible outcome. So this is also called a discrete probability distribution because the outcomes are coming from a discrete random variable. Okay, x is a discrete random variable 0, 1, 2, 3 because you can count it and it's random. Now, one thing that a discrete probability distribution has to satisfy is that the sum of all the probabilities must equal 1. So if you add up all of these probabilities, okay, so if you go probability of x equals 0 plus the probability of x equals 1 plus the probability of x equals 2, right? You're adding up all of these probabilities, so that's the sum. So you go 1 over 8 plus 3 over 8 plus 3 over 8 plus 1 over 8. And what do you end up with? 1 plus 3 is 4, plus 3 is 7, plus 1 is 8, is 8 over 8. So it has satisfied one of the rules, is that all of these probabilities must add up to 1. Another rule that it also has to satisfy is that each of these probabilities are between 0 and 1. So you can see here every probability is between 0 and 1. Okay, so that's between 0 and 1, that's between 0 and 1. Okay, so basically these are the two rules that a discrete probability distribution has to satisfy. Okay, so that concludes our first probability lesson. If you have some idea of what is a discrete random variable, which is x, which is the number of heads obtained from a coin toss, or the number of picture cards drawn from a deck of cards, these are all discrete random variables. And then a discrete probability distribution is assigning probabilities to these discrete random variables. So next lesson we're going to start talking about how to actually calculate these probabilities. Okay, thanks for watching guys, see you next time.